All of the problems covered in my videos can be downloaded at statisticsworkbook.com. If you go to the website, click on the PDF. You can download a copy of the workbook for yourself. Also on the website, you'll find links to all of my statistics videos, not just the ones I've uploaded to YouTube. I've uploaded nearly 100 videos that you cannot find on YouTube. So, I do hope you'll check out statisticsworkbook.com. Alright, let's begin our problem. Okay, welcome back. Here's another exercise looking at the uniform probability distribution. So here we're looking at taking university courses. Everybody knows, myself, I'm guilty of doing this too in a lecture. Sometimes you talk about something, brings an idea to mind and you veer off topic, and instructors always think it's the most interesting thing in the world, but the students are probably waiting for the class to end no matter what the instructor is talking about. So let's assume that during a 50-minute class, the instructor spends an average of 10 minutes talking about something he or she finds interesting, but it's irrelevant to the course. Let's assume further that the amount of time lecturing is uniformly distributed between 35 and 40 minutes. So part A, draw the graph of this probability density function. So here we're going to have something that looks like this. Here's f of x, this is our density function. Here's values that our variable of interest x can assume. And this is uniformly distributed between 35 and 45. So let's say this is 35, this is 45. Now we need to figure out what's the height of this probability density function. So if we just plug our numbers into this formula, b minus a, in this case 45 is b, 35 is a. So this is 1 over 45 minus 35. So that's 1 over 10. So there's our height, 1 over 10. And we have our probability density function looks something like this. Good. What is the probability that a class will have 42 minutes or more of relevant lecturing? So here we're going to look at calculating the area under this curve, because this is how probabilities are calculated now when we're working with density functions. Probabilities are represented by the area under the curve. So if we have a value, let's say 42 is right here. So now we're looking at calculating what is this area here. Now the question says 42 minutes or more of relevant lecturing. But given that it's distributed between 35 and 45, anything beyond that, beyond 45, the probability of the density function takes on a value of 0. So saying 42 minutes or more, this is just like asking us what's the probability that x is greater than or equal to 42 or less than or equal to 45, because 45 is the maximum value that exists within this distribution. So this can be obtained by calculating f of x times the width of that interval, b minus a. In this case, b is 45, a is 42. So this is 1/10 times 45 minus 42. So this is going to be now 0.1 times 3, so 0.3. Oops. So there's our probability, 42 minutes or more. Call it a 30% chance that the class will have 42 minutes or more of relevant lecturing. What is the probability that the class will have between 38 and 42 minutes? So again, now we're looking at, let's just erase the irrelevant bits here. So we have now a problem 38. So let's call this 38, and here's 42. So now we're looking at this area under the curve. So this is 1/10 times, now we have here 38 to 42. So this is 42 minus 38. So that's 1/10 times 4 30.1 times 4 0.4. Easy enough. 0.4. 40% chance that it will be between 38 and 42 minutes of relevant lecturing. What is the probability that a class will have less than 40 minutes of relevant lecture? Okay, so let's find, whoops, where's my eraser when I need it? So let's say 40, so here's 40, less than 40, well the minimum value this distribution has is 35, so we're in this space here. So this is between 35 and 40. So this function still has the same value, 1/10 times 40 minus 35. So that's going to be 1/10 times 5, that's going to be 0.5. Good, we're getting there. Okay, last problem. What is the probability that a professor spends more than 12 minutes off topic? So this question is sort of being asked in reverse, right? The other ones we're talking about the number of minutes of relevant lecture. This one we're talking about the number of minutes spent off topic. So if we have 12 minutes off topic, then what that means is out of that 50 minutes class, it means we have at least 38 minutes on topic. So we're looking at 12 minutes off topic is 38 minutes on topic. And here we're looking at spends more than 12 minutes off topic. So that means 38 minutes or less of relevant lecturing. And so again, less, well, the minimum here is 35. So the lowest possible value, of course, is going to be 35. So this is going to be 35 to 38. 1/10 times 38 minus 35. So this is 1/10 times 3, so here's 0.3. So 30% chance that this professor spends more than 12 minutes off topic, which is the same as saying more than or less than 38 minutes on topic, because the maximum class is 50. 50 minus 12 minutes, of course, that's where our 38 comes from. And there you have it. Okay, so hopefully that all makes sense. We went through that a little bit quick, but these calculations, no, the calculations are relatively, I hope, relatively straightforward for you. Okay, good. Thank you for watching. Bye-bye.